Okie dokie. Hello everybody. Welcome to the Numpy lesson. Let's get started. So we'll be talking about what Numpy is, how to install it, and then arrays and operations are what you're going to be doing with Numpy. So to begin, what is Numpy? Numpy is a linear algebra library commonly used for data science. It can be used for manipulating and storing data in arrays, which is useful for creating and using data from pandas data frames. We'll cover pandas and pandas data frames in a subsequent lecture. Numpy is very, very important because many other libraries in data science rely on Numpy as the very foundation, one of the most basic building blocks upon which to build their libraries and all the fantastic things that they can accomplish. So, how do you install it? In your command prompt, you'll type in conda install numpy if you have the Anaconda distribution, or if you don't, you can type in pip install numpy. So, open up your command prompt by typing it into the search bar, conda install numpy, if you have it. If you don't have it, then pip install numpy. That's going to take a minute to install. I already have it installed, so I won't waste your time with that. Now, importing in Python. To import it into your notebook or to any of your projects, you're going to use import numpy as np, typically at the top of your project. Now let's talk about arrays. Let's get right into it. Arrays are similar to a list, but all of their items in it have to be identical data types. So you can't have a string that says bananas and the number 6. They need to be all strings or all numbers or all booleans, etc., etc. It can be used to contain all those great things, but they need to be the same. So an array with other arrays in it is called a two-dimensional array or a matrix. So an array of arrays. And if it doesn't have that, if it's just a plain old regular fashion array, it's called a one-dimensional array or a vector. Every item in an array is assigned an index depending on its position. This lets us easily access data from arrays. So this visual explains that pretty well. You have all your values, and each of those values is assigned a number starting from 0, not 1, 0. Very important. And we'll talk about that in just a minute. So if you want to make a list into an array, you're going to use this syntax, np.array, name of your list. So right here, you can see we have my list, and we made a list. Now we have np.array, my list, and it turns it into an array. That's what that looks like. This just says an array has to have the same data type, so we already covered that. Now let's talk about some useful array methods. What can you do with them? So to begin, np.arange can be used to create a quick list of numbers arranged in a linear fashion. So let's actually make this a little bit simpler to begin. np.arange 0 to 10. It creates an array from 0 to 10 exclusive, so up to but not including 10. And then if you want to make it a little bit more complicated, you can pass in a third argument. So this is kind of the default, 1, meaning it increases by 1. So this is called the step argument, by the way. So that's how much it increases by every time. So if you want to say, if you put 2 in here, it'll increase by 2's each time. So 0, 2, 4, 6, 8. Again, the next one would be 10, but again, up to not including 10. So step is how much you increase by each time. And then np.zeros creates a vector, so a one-dimensional array of 3 zeros. And if you want to pass in a tuple, that can create a matrix of rows and columns. So you'll see that illustrated right here. You pass in one number, and you get an array of that many number of zeros. If you want to make a matrix, or an array inside of an array, you can have np.zeros, and then you pass in a tuple, so number of rows, number of columns, separated by a comma, and surrounded by parentheses. Very important that you have these parentheses there. If you don't have these parentheses here, it will throw an error. So very important, if you have an error with your zeros matrix, make sure that you have parentheses around your arguments. There you go. np.ones is the same thing but with ones. So if you have 5, you get an output of 5 ones. If you have 3, 3, again surrounded by parentheses, then you have 3 rows and 3 columns of ones. And now we can talk about np.linspace. and np.i. So np.linspace can be used to create an array of a number of evenly spaced points between two given numbers. So, and in this time, worth noting, the stop is inclusive this time. With linspace, you can create 0 up to and including 10. So in this case, we have 0, 10, and then 6 is the number of evenly spaced points that we want. So 0 to 10, we have 6 evenly spaced points. 0, 2, 4, 6, 8, 10. That's 10. And then np.i creates a square matrix. So number of rows is the same as the number of columns. And then it has all zeros except for a diagonal of ones. This is also known as an identity matrix, and it's useful for linear algebra problems. So here we have 4, np.i 4. So it has 4 rows and 4 columns, and that diagonal of ones that we talked about. Moving on, talk about some more. Here we have a regular old array, 2, 1, 4, 3. So then we're going to talk about some more basic methods. So reshape reshapes it from a one-dimensional array or vector into a matrix with two rows going this way and 2 columns going this way. arr.max. So the .max method returns the maximum value. So in our array we have 2, 1, 4, and 3. So 4 is our maximum value. arr.min is the same thing but with a minimum number, which is 1. arr.argmax. This returns the location of the maximum value. So remember how we were talking about indexes? This is a good way to illustrate it. So our maximum value is 4. If we're numbering the items in the array from 0 onward, then 2 would be assigned 0, the index of 0. 1 would be assigned the index of 1. 4 would be assigned the index of 2, and 3 would be assigned the index of 3. 0, 1, 2, 3. So therefore 4 is located at index 2, and therefore arr.argmax returns 2. arr.argmin is the same thing but with a minimum value. So if we have a minimum value of 1, we have 0, 1. So arr.argmin returns 1. And now arr.shape returns the shape of the vector or matrix. So in this case, the original ARR is just a one-dimensional vector consisting of 4 elements. So it returns 4. If the original ARR was a matrix, a 2 by 2, it would have returned 2, 2. And then arr.dtype returns the data type of the items in the array. So 64-bit integer, that's the data type. That's that's just numbers. And it is very important to note that shape and dtype are attributes. They are not methods. They do not have parentheses at the end of them. If you put parentheses at the end of them, they will return an error. Argmin, argmax, minmax, those are things that you are doing to the array. You are, taking something from it. Shapes and dtypes, that's just things about the array, essentially. Shape and dtype, no parentheses. Everything else you can put parentheses.